So we're going to add and subtract fractions. Now, in your previous lesson, you learned how to find common denominators. And the whole reason to find a common denominator is so that, and find equivalent statements with the common denominators, is so that you can add and subtract fractions. So I have two problems here, one subtraction with a denominator that's already common, and the other with a addition, and the denominators are not common. So let's take a look at our first example. We have y minus 2 over 3 minus 3y minus 5 over 3. Now, the first thing I notice is I have common denominators. The denominator is 3. So I don't need to do any conversion whatsoever, because you can only add or subtract when you have common denominators. Since they're common, I don't have to subtract. So really, I know right off the bat that my answer is going to have a 3 in the denominator. So then I'm just going to look at the numerators, and if this were a normal problem, for example, if I had 5 over 6 minus 1 over 6, I would end up with 6, and I would just subtract 5 minus 1 to get 4, and then obviously in this example I'd have to convert to 2/3. So what I'm going to do here is I'm going to subtract the common terms. So what's common to y? Well, 3y. So I have y minus 3y, which is negative 2y. Because if I have 1y and I take 3 y's away, I have negative 2 y's. If I have negative 2 minus 5, well, subtracting a negative is the same as adding a positive. So negative 2 plus 5 is plus 3. Now, there are two common mistakes in subtraction with polynomial expressions. The first mistake is that students sometimes falsely think that you just have negative 2 minus 5 and end up with a negative 7. That's not true, because you are subtracting them. And so you have to remember that you're doing negative 2 minus negative 5. The other common misconception, and hopefully once you've gotten to this point you don't have this misconception anymore, is that you can factor or reduce right here. Well, 3 and a 3. You can't do that, because really what this is saying is you have negative 2y divided by 3 plus 3 over 3. If you were to just cancel out the 3's, then the denominator for this one disappears, and they're not equivalent statements. So you can't reduce this anymore. This is just what it is. That is the answer. So in my second problem, I have two fractions, and in this case I don't have common denominators. I have 4 over x squared minus 1 and 2 over x squared minus 2x minus 1. What am I going to have to do with this denominator? I'm going to have to factor it. So there's no common monomial for x squared and negative 1. So therefore, I have to look at other forms of factoring. And I notice that this is a difference of squares, because x squared is a perfect square and 1 is a perfect square. So I am going to rewrite the fraction. And so I have a pair of binomials. And in a difference of squares, 1 is going to be positive, 1 is going to be minus. And the square root of x squared is x. So I have an x here and an x here. Square root of 1 is 1. So that's what I have here. For my second problem, I still have a 2 in the numerator, and I have x squared minus 2x minus 1. And can this be factored? I'm not sure. I'm not sure that it can. I am willing to bet that I have a typo on the page. Is that what's written on the page? Are you sure it isn't plus 1?
Yeah.
It is plus 1. Now, I realize that this is not written correctly because this is a prime expression. It cannot be factored. If it's plus 1, it can be, and we'll show you how. So, x squared minus 2x minus 1, they don't share a common monomial. this is a trinomial, so it's probably not a difference of squares. So I'm going to have to factor this using my rectangles or my sum and factor table. So if I'm using a factor sum table, I'm looking for factors of 1 that have a sum of -2. Well, what are the factors of 1? 1, 1, and 1, and -1, and -1. 1 plus 1 is 2. Nope. -1 minus 1 is -2. That works out. So this can be factored as x minus 1 times x minus 1. Obviously, it can be written as x minus 1 squared, but we don't want to do that right now. We want to keep it in this sort of expanded form. So what is my common denominator for this one?
X minus 1.
Well, we have an x minus 1 in both of them, right? We have an x minus 1 here, we have an x minus 1 here. But wait a second. That only accounts for one of the x minus 1s, and it doesn't account for the x plus 1, does it? So my common denominator is going to have to include 1x plus 1, and it's going to have to include 2 x minus 1s, doesn't it? So my common denominator is going to end up being x plus 1 times x minus 1 times x minus 1. Because this has 2 of them, so it has to have 2 of them in the denominator. This has an x plus 1, so therefore we also have to have an x plus 1. So let's rewrite this fraction. I'm going to try to write it a little bit smaller. What am I going to have to multiply this fraction by to get a common to the common denominator? Well, it has an x plus 1, so I don't have to multiply by that. And it has 1 x minus 1, so I don't have to multiply by that. That leaves that, doesn't it? That extra. So I'm going to multiply this by x minus 1 over x minus 1. I'm still adding. Over here we have 2 over x minus 1 times x minus 1. What is this expression missing? Well, it has these 2 x minus 1s, but it is missing this x plus 1. So I'm going to have to multiply by x plus 1 to the numerator and the denominator. So let's see what we get. So we have 4 times x, 4 times -1. And so I end up with 4x minus 1 over my common denominator, x plus 1 times x minus 1 times x minus 1. And I'm going to add that to this. Distribute the 2. 2 times x is 2x. 2 times 1 is 1 over my common denominator, x plus 1 times x minus 1 times x minus 1. So now, to give myself some more room, I'm going to attempt to shrink what I have. Oh, come on, folks. I love this little shrink function. Okay. So there we have it, and I have plenty of room now. So now, I just add the common terms. 4x plus 2x is 6x. -1 plus +1 is 0. And this is all over x plus 1. Now, x minus 1 times x minus 1, as we alluded to earlier, can just be expressed as x minus 1 squared. And there is our answer. So those are 2 examples of how to add and subtract fractions when you have polynomial expressions in the fraction.